To obtain your electrician certification in Georgia, there are several steps that need to be followed. Firstly, you must meet the prerequisites, which include having a high school diploma or its equivalent and being at least 18 years of age. Secondly, it is important to find an approved apprenticeship program. This can involve joining a union apprenticeship program with the International Brotherhood of Electrical Workers (IBU) or a non-union program approved by the Georgia Electrical Contractors Association (GECA). Thirdly, prepare to pass the entry-level exam. This usually involves taking and passing the National Electrical Aptitude Test (NEAT), which will assess your basic electrical knowledge and skills. Fourthly, you must complete the apprenticeship program. This typically involves 4 to 5 years of on-the-job training and classroom instruction, covering all aspects of electrical work including wiring, installation, maintenance, and repair. Fifthly, dedicate time to study for the journeyman's exam. This exam tests your knowledge of the National Electrical Code, NEC, and other industry standards. Study materials include textbooks, practice exams, and online resources. Sixthly, you'll need to take the journeyman's exam administered by the Georgia Department of Labor. Passing this exam grants you a Class 2 electrician certification. In addition to these steps, there are some additional tips that can be helpful in obtaining your electrician certification. 1. Get involved in industry organizations such as GECA or IBU for networking and training opportunities. 2. Seek mentorship from an experienced electrician to provide guidance and support. 3. Stay up to date on industry codes and standards by regularly reviewing the NEC and other relevant documents. 4. Practice electrical skills, as hands-on experience is essential for developing proficiency. 5. Be patient and persistent, as it can take time and effort to become a certified electrician, so stay dedicated and don't give up on your goals. Remember that the National Electrical Code, NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. Familiarity with the NEC is absolutely essential for all electricians. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC covers a wide range of topics, including general wiring requirements, overcurrent protection, grounding, wiring methods, equipment installation, and special occupancies. Let's delve into some key areas you'll encounter in your journey to becoming a certified electrician, drawing upon knowledge found within the NEC and general electrical practices. First, understanding the fundamentals of electrical theory is crucial. This includes Ohm's law, which describes the relationship between voltage, current, and resistance. The formula is voltage equals current times resistance, or volts equals amps times ohms. Knowing how to apply Ohm's law is essential for calculating circuit parameters and troubleshooting electrical problems. You'll also need to understand series and parallel circuits and how to calculate total resistance, current, and voltage in each type of circuit. Second, wiring methods are a fundamental aspect of electrical work. The NEC specifies approved wiring methods for different applications such as residential, commercial, and industrial. Common wiring methods include non-metallic sheaths cable, often called NM cable or Romex, which is typically used in residential wiring. Another common wiring method is electrical metallic tubing (EMT), a type of metal conduit used in both residential and commercial applications. Rigid metal conduit (RMCE) provides even greater protection for wiring in harsh environments. Understanding the appropriate uses and installation requirements for each wiring method is essential. Third, grounding is a critical safety measure in electrical systems. Grounding provides a low impedance path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies grounding requirements for different types of systems and equipment. Key concepts include the grounding electrode system, which connects the electrical system to the earth, and equipment grounding conductors, which provide a path for fault current from equipment back to the source. Fourth, overcurrent protection is another vital safety feature. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that could cause overheating and fires. The NEC specifies the required overcurrent protection for different types of circuits and equipment. It's important to understand how to calculate the correct size of circuit breakers and fuses based on the opacity of the conductors they protect. Fifth, load calculations are necessary to determine the appropriate size of electrical services and feeders for buildings. The NEC provides detailed methods for calculating the electrical load based on the square footage of the building, the types of appliances and equipment installed, and other factors. Accurate load calculations are essential to ensure that the electrical system can safely handle the expected demand. Sixth, working with electrical drawings and diagrams is a common task for electricians. Electrical drawings show the layout of electrical systems, including the location of outlets, switches, lights, and other equipment. Diagrams, such as single-line diagrams and wiring diagrams, provide detailed information about the connections between different components. Being able to read and interpret electrical drawings and diagrams is essential for installing and troubleshooting electrical systems. Let's consider some specific examples. For residential wiring, understanding the requirements for branch circuits is crucial. A typical 15-amp branch circuit, operating at 120 volts, can supply a limited number of outlets and lights. The NEC specifies the maximum number of outlets allowed on a 15-amp or 20-amp circuit. Also, the NEC mandates the use of ground fault circuit interrupters, GFCIs, in areas where electrical outlets are near water, such as bathrooms and kitchens. GFCIs protect against electrical shock by detecting small imbalances in current and quickly shutting off the power. For commercial wiring, you will encounter three-phase power systems. Three-phase power is more efficient for powering large equipment such as motors and HVAC systems. Understanding the different types of three-phase connections, such as Y and delta configurations, is essential. You'll also need to know how to calculate voltage and current in three-phase circuits. Commercial buildings often have complex lighting systems, including fluorescent and LED fixtures. The NEC specifies the requirements for installing and wiring these types of lighting systems. You'll also need to understand the requirements for emergency lighting and exit signs. For industrial wiring, you may encounter hazardous locations where flammable gases or dusts are present. The NEC classifies hazardous locations into different classes and divisions and specifies the types of equipment that are permitted in each location. Explosion-proof enclosures are used to protect electrical equipment in hazardous locations. You'll also need to understand the requirements for grounding and bonding in industrial facilities. The NEC contains numerous tables that are essential for electricians to use. For example, NEC Table 310.16 provides the ampacity of conductors based on their size and insulation type. The ampacity of a conductor is the maximum current it can safely carry without overheating. NEC Table 250.122 provides the minimum size of equipment grounding conductors based on the size of the overcurrent protection device. NEC Chapter 9 contains tables that provide information about conduit fill, box fill, and other calculations. Staying up to date with the latest edition of the NEC is critical. The NEC is updated every 3 years, and each new edition includes changes and revisions to the code. You can purchase the NEC from the National Fire Protection Association (NFPA) or access it online through a subscription service. Many training providers offer courses on the NEC which can help you understand the changes and how they affect your work. It is important to understand that electrical work is inherently dangerous, and it is essential to follow safe work practices at all times. Always to energize circuits before working on them and use appropriate personal protective equipment (PPE) such as gloves, safety glasses, and arc flash protection. Lockout/tagout procedures are used to prevent accidental energization of circuits during maintenance and repair. Electrical safety training is essential for all electricians, and you should regularly participate in refresher courses to stay up to date on the latest safety practices. Remember, becoming a certified electrician is a challenging but rewarding career path. By mastering the fundamentals of electrical theory, understanding the NEC, and following safe work practices, you can build a successful career in the electrical field.